Let's move on to the traffic density. It is defined as the number of vehicles occupying some length of roadway at some specified time over the length of the roadway. It can also be related to the individual spacing between successive vehicles, measured from the front bumper to the front bumper of the next vehicle. The roadway length L in equation 4.10 previously can be defined as the summation of the spacing of the ith vehicle, the distance between vehicle I and I-1, measured from front bumper to front bumper. So N here is the number of measured vehicle spacing. So basically, you will have to determine the space between vehicles on a certain length of the roadway. Substituting equation 4.11 into equation 4.10, it gives the density is equal to the number of vehicles over the summation of the spacings between the vehicles. Or K is equal to 1 over S bar, which is the average spacing between the vehicles. And then the density will be calculated by 1 over that certain average spacing that was calculated. Next is, we will look at the relationships between the traffic analysis variables, which is the speed, the flow, and the density. The time, headway, and the spacing are referred to as microscopic measures because they describe specific characteristics to individual pairs of vehicles within the traffic stream. Measures that refer to the traffic stream as a whole, such as the flow, average speed, and density, are referred to as macroscopic measures because they describe characteristics of the traffic stream as a whole. As indicated by the equations we have seen in the past slides, the microscopic measures can be aggregated and thus it can be related to the macroscopic measures, which are the flow, average speed, and the density. Based on the definitions, a simple identity provides the relationship of traffic flow speed or space mean speed and the density, denoting space mean speed US as simply U for notational convenience. Now, this is the relationship between the three, the flow, speed, and density. Flow is equal to speed times density. Flow is in vehicles per hour, speed is in kilometers per hour, and density is. This shows you the speed and density relationship. We can see here in the x-axis, this is the density and this is the speed. So they have a linear relationship. We have this relationship formula where U is the space mean speed and UF is the free flow speed, and K here is the density in vehicle per kilometer, and KJ is the jam density in vehicle kilometer. So take note that during the free flow speed, the density is 0. And while the density is becoming more closer to the jam density, the speed also decreases. They have this linear relationship. This slide shows you the relationship between the flow and the density. Looking at this figure, this is the x-axis is the density and the y-axis is the flow in vehicle per hour. Notice that from 0, the highway has certain capacity of traffic flow. And it has a certain maximum capacity. So When the traffic flow is according to the highest rate or capacity of the highway, then the density is at corresponding traffic density. So notice also here that when the flow is over the capacity, then the density boils to the jam density. Now, this is the formula for the relationship between the flow and the density. And this is the relationship between flow and speed. So at a certain capacity of flow, the speed is at the capacity speed. And this is the formula for the relationship between the flow and the speed. So in summary, this graph shows you the relationship of density and speed, flow and speed, and flow and density. So this ends the overview of Chapter 4, Elements of Traffic Analysis. Thank you for listening and see you in the next coming videos.